The quadratic function. A quadratic function is a function defined by f of x is equals to ax squared plus bx plus c, where a, b, and c are real numbers and a not equal to 0. The domain of the quadratic function is the set of real numbers. The first term, ax squared, in the quadratic function is the quadratic term. The second term, bx, is the linear term. And the last term, c, is the constant. For given pairs of values, one can determine whether the function represented is linear or quadratic. Consider the tables of values representing the function f of x is equals to 2x plus 1 and g of x equals to 2x squared plus 1 in the examples that follow. Example: first function, f of x is equals to 2x plus 1. Let's draw a table. Okay. This is the value of our x. Right here, f of x. Our x is negative 2, negative 1, 0, 1, 2, and 3. Now we need to find the value of our f of x using these values of x. So first, if our x is equals to negative 2, we need to find the value of our f of x using the function 2x plus 1. So f of x is equals to 2. Substitute the value of our x, which is negative 2, plus 1 is equals to negative 4 plus 1 equals negative 3. So the value of our f of x, if x is equals to negative 2, is negative 3. Next, if our x is equal negative 1, we need to find the value of our f of x, 2x, using the function 2x plus 1. So f of x equal to times negative 1 plus 1. So our f of x, or the value of our f of x, is equal to negative 2 plus 1, which is equals negative 1. So if our x is negative 1, the value of our f of x is negative 1. Next, if our x is equal to 0, we need to find the value of our f of x, which is equal to 2x plus 1. So f of x, substitute the value of our x, 2 times 0 plus 1. So the value of our f of x equals to 1. If our x is 0, our f of x equal to 1. Next, if our x equal to 1, what is the value of our f of x using the function 2x plus 1? So our f of x equal to times 1 plus 1. So our f of x equal to plus 1 is equal to 3. So this is the value of our f of x if our x equals to 1. Next, what if our x equal to 2? We need to find the value of our f of x, which is equal to x plus 1, or using the function 2x plus 1. So f of x equal to times 2, which is the value of our x, plus 1 equals to, equals 4 plus 1, which is equal to 5. And this is now the value of our f of x, if our x is equals to 2. Next, last, if our x equal to 3, to find the value of our f of x, okay, 2 times 3 plus 1, 6 plus 1, 7. So this is the value of our f of x if our x is equals to 3. The value or the table of values for the linear function f of x is equals to 2x plus 1 shows that equal differences in x produce equal differences in f of x. Yes, because as what you can see, when we get the difference in the value of our x, or the differences in the value of our x, it's the same, which is 1, the difference 1, 1, 1, and 1, while in our f of x, the difference is 2, 2, 2, 2, and 2. And that's why the equal differences in x produce an equal differences in f of x. And now let's proceed to example number 2. We have a function g of x, 2x squared plus 1. This is the value of our x and g of x. Okay, so negative 2, negative 1, 0, 1, 2, and 3. Okay, let's try to get the value of our g of x. Let x equals to negative 2. So our g of x equals to 2x squared plus 1. G of negative 2, 2 times the value of our x, which is negative 2 squared plus 1 is equals to 2 times the square of negative 2 is positive 4 plus 1 is equals to 8 plus 1, which is equal to 9. And that's the value of our g of x if our x is equals to negative 2. Next, if our x is equal to negative 1, our g of x, 2x squared plus 1, 2 times negative 1 squared plus 1, 2 times the square root of negative 1 is positive 1 plus 1, which is equal to 2 plus 1 equal to 3. And that's the value of our g of x if our x equals 1, negative 1. Next, let x equal to 0. So our g of x 2x squared plus 1, 2 times the value of our x, which is 0, squared plus 1. So 2, the square root of 0 is also 0, times 2. So 2 times 0 is 0 plus 1, which is equal to 1. If our x equals to 0, so the value of our g of x equals to 1. Next, let x equal to 1. So our g of x equal to 2 times the value of our x, which is 1, squared plus 1 is equal to 2 times the square root of 1 is also 1 plus 1 is equal to the product of 2 times 1 is 2 plus 1 equal to 3. So the value of our g of x is 3 if our x equal to 1. Next, let x equal to 2. The value of our g of x, 2x squared plus 1 equal to 2 times the value of our x, which is 2 squared plus 1 equal to 2 times the square root of 2 is 4 plus 1 equals 8 plus 1 equal to 9. And that's the value of our g of x if our x is equals to 2. Next, if our x equal to 3, our g of x, 2x squared plus 1, using the function 2x squared plus 1 is equals to 2 times the value of our x, which is 3 squared plus 1 equal to times the square root of 3 is 9 plus 1 equals 2 times 9 is 18 plus 1 equals 19. And that's the value of our g of x if our x is equals to 3. It's 19. So as what you can see, the difference is also the same, 1, 1. But the difference here is negative 6, negative 2, 2, 6, and 10. This is the first difference. And then the second difference, 4, 4, 4, and 4. The second difference, they are all equal, which is 4. Observe that the x values used in the table above or in the table are consecutive integers from negative 2 to 3. That this time, the first differences in g of x are not equal, but the second differences are equal. That is, the second differences in g of x is 4. The table of values for quadratic function g of x is equals to 2x squared plus 1 shows that equal differences in x produce equal second differences in g of x. Okay, so can you now state how the two functions differ in terms of their respective table of values? So that's it. And now you can now identify what is the difference between the two given function. Thank you.